All right, so yesterday was a lot of problems that had to do with the properties themselves algebraically. Like we'd set up an equation, solve it, not too bad, right? Today is more of the graphing end of it. We're still going to use the properties, but we're going to graph it. We've got some steps to walk us through it. So on your paper, there's a graph here. We're going to graph a parallelogram. But what do you notice is weird about the parallelogram? Question? Yeah. What do you notice about the parallelogram? JKLM. As you read through it,
You have to find them.
you have to find one of them. They give you J, they give you K, they give you L. They don't give you M. So that is part of the process here. Now, honestly, it's pretty easy if you are careful as you graph and label. All right, so let's graph 3, -8. 1, 2, 3. -8, which is J. Don't be lazy. Put the letter and the coordinates there. K is -2, 2. L is 2, 6. And we're trying to find M. Okay. The parallelogram's name is JKLM. I'm going to point something out to you real quick. So I need you to pause what you're doing for a minute, just a couple seconds actually, and look up here because I have students do this every year. All right. How many of you can see a parallelogram where if I were to connect these and go down maybe to here, M could be down here? How many of you see that? It could be off the page down here and make a parallelogram. Can you see that? How many of you see a parallelogram if I go J, K, L, M and put M here, I could make another parallelogram, right? There's 2 possibilities, but its name is J, K, L, M. This is the one, this is the area where it has to go. You understand that? Because of the order, it has to be named in a certain order. So when we go to find M, it's going to be over here. Now, how do we find M? Well, step 1, graph it. Perfect. Step 2, find the slope of KL by counting. Now, 2 choices. I could go from K to L or I could go from L to K. I'm going to get the same slope. Do you see how it makes more sense to go from K to L? Because then I can go from J to M over here. Because if I went backwards, if I went from L to K, I wouldn't know where to go from M to J because I don't know where M is, right? So I'm going to go from K to L. From K to L, I have to rise 1, 2, 3, 4. I have to rise 4 and run 1, 2, 3, 4. I have to rise 4 and run 4. Which means from J to M, I'm going to also rise 1, 2, 3, 4 and run 1, 2, 3, 4. So that gives me the coordinates of M. Does that look reasonable for a point? Okay. Now we have to find its coordinates. Well, the x comes first. What happens if I run 4 from an x value of 3? Now I'm at an x value of 7. And if I rise 4 from a y value of -8, now I'm at a y value of -4. And we connect those, and we've just graphed parallelogram JKLM. And do you see how we used the definition of a parallelogram to do that? What's the definition of a parallelogram? Who can raise their hand and remind me? A quadrilateral with, which one? 2 pairs of parallel sides, right? 2 pairs of parallel sides. Well, how did we use that? Well, by finding the slope and noticing opposite sides have the same slope and using that slope to find that coordinate, we made them parallel. Do you agree? Now, could we have done the same thing from Could we have done the same thing from, watch up here, from K to J, count down and over, and then use that same slope from L to N? Yeah, that's fine too. There's that's two perfectly fine options to solve that. Questions on that process? That's only if they say to find that missing coordinate, find the missing point to make it a parallelogram. Next, find the coordinates of the intersection of the diagonals of parallelogram LMNO, and it gives you all four vertices and all four coordinates. So this is not the same problem we just did. This is different. Okay, let's graph it first, then we'll get into what we're actually going to do here. So L is 1, 4. 1, 2, 3, 4. M is 7, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 6, 0. 1, 2, 3, 4, 5, 6. And 0, 0. All right. So L, M, N, and O. All right, let's read the directions again. Find the coordinates of the intersection of the diagonals. Well, it makes sense to draw on the diagonals, doesn't it? Let's draw on the diagonals. So do you see how it's asking us for the coordinates of the intersection of the diagonals? In other words, find the point where they cross, right? Find the point where they cross. How do you think we should go about doing that? How would you find the point where they cross? Emma.
The midpoint formula.
Yeah. Why?
Because since the diagonals bisect each other, that they're equal. So that
Very
they
good.
have to be the midpoint.
Yeah, so yesterday we saw if you draw a diagonal and you draw another diagonal, these are congruent, and so that point is the midpoint of both diagonals, right? It's the midpoint. Oh, midpoint formula, that makes sense. Do you remember what the midpoint formula is, or do we want to call on someone else, Emma?
X1 plus X2 over 2, and then Y1 plus Y2 over 2.
Yep. Yeah, middle, average, right? Add two things together, divide by 2. All right, let's do the midpoint of LN. Ln. Well, L has an x value of 1. N has an x value of 6. So 1 plus 6 divided by 2. And I'm going to add the y values, 4 plus 0, and divide by 2. I'm getting 7 divided by 2, which is 3.5. And then 4 divided by 2, which is 2. Now, these last two problems, the last slide we did, I would definitely graph that, right? Graphing it, use the slopes. That's a very visual problem. This one, I don't know that you'd have to graph this one, but I think it does help to kind of visualize it. Does 3.5 comma 2 seem reasonable for this answer? 1, 2, 3.5 comma 2. Does it seem reasonable? Yeah, I mean, I should have probably used the line tool as I drew my diagonals in. Maybe I'll do that. See how close we can get there. If you actually use the line tool. Yeah, I think that looks pretty reasonable to me. Yeah, perfectly straight. And you could use a straight edge. But we're kind of relying on the math here, adding two numbers divided by 2. Kind of trust that process. So that's my first midpoint. Do I need to do the second midpoint? No, I know the diagonals bisect each other. They cut each other in half. They meet at the same point. The other one's going to have the same point. But since we're still new to this process, it doesn't take long. Let's do the midpoint. By the way, if I were doing a quiz, I'd probably do the second one to make sure I get it right. Midpoint of OM. 0 plus 7 divided by 2, and 0 plus 4 divided by 2. And sure enough, 3.5 comma 2, which means they have the same midpoint. Does that mean the diagonals are congruent? There's a lot of vocabulary going on here. Because they have the same midpoints, does that mean that diagonals are congruent, the same length? No. Remember my example? Can you have two segments that cross at each other's midpoints where the segments are not congruent? Yes. So just because the diagonals cross at each other's midpoints does not make them the same length. You understand that? Okay. And visually, I think students have trouble with that sometimes because I don't know if that, do they look congruent to you? You be honest. If you think they look congruent, I could understand that. Who thinks they kind of look congruent? Okay. And I have a way to kind of show you if they are not. And this will matter later on, so it's worthwhile. Now, unfortunately, with this software, I can't turn the picture without it stretching, but I can do a little screen capture just to kind of compare them. So we'll do that. Where's the picture? There it is. Come on. That one. A little sensitive today. Try to make it as close as possible. That's pretty close, right? Yeah. All right, so that I can rotate. And it's kind of weird how much our eyes can deceive us, okay? They're not the same length, are they? Right? Actually, off by quite a bit in the grand scheme of things. Now, like I said, we are going to be heading there in a little while, in a few sections where when would the diagonals be congruent? Because they're not congruent here. They cut each other in half, but they're not congruent. What kind of shape would have congruent diagonals? Anybody know? Square, rectangle, you guys agree? Have you learned that before? No? Okay. So this process, they have the same midpoints. They have the same midpoints. That makes them bisect each other. And if you really wanted to, you could name, well, they've already used the letter M. You could call it letter A, whatever you wanted, as long as you label it appropriately. All right, next one. We have two parallelograms up here. We're asked to prove that a pair of angles are congruent. Take just a few seconds and think through this. Think about what you would do here. Triangles are out. No triangles in this one. So there's no such thing as SSS, SAS, all that stuff for parallelograms. So we have to get there another way. Anybody have a plan they think would work? Or at least would be willing to say it out loud and get us started.
Vertical angles.
I see vertical angles for sure. I like that. So before, this is like my pre-proof kind of brainstorming. Okay, I see vertical angles here. Those are congruent, right? What else? So the online portion, you know how you go to our online book. It's under assignments, and I've already decided to you. So if you can't get to it, just let me know. Right. Anybody have any other ideas? Emma.
Opposite angles are congruent as one of the properties of parallelogram.
Good. So let's work maybe from left to right. Angle G. I can name angle G with one letter, right? There's only one angle there. Angle G is congruent to angle HJN. HJN or NJH, either one. Agree? Reason? In a parallelogram, opposite angles are congruent. And what's the theorem that it's called? Emma's got it right in front of her.
Properties of parallelogram.
Yeah, which one was that? Oh, you know what? We didn't write down the name of the theorem. If you just put opposite angles are congruent, that's fine. I think this new book actually calls it the opposite angles theorem, doesn't it?
Yeah.
Okay, opposite angles theorem. Now, then we use Olivia's vertical angles. And then what? Angle KJM is congruent to angle L. Reason? Opposite angles theorem. Now tell me if you recognize this guy. If G's congruent to HJN and HJN's congruent to KJM, then G's congruent. Sorry. You'd string them together. This part's congruent to this one's congruent to that one, so that one's congruent to that one. You see the transitive property there? I heard someone say it. Okay. So that's kind of our process. But first, we have to start off by saying that they are parallelograms. So GHJN and JKLM are parallelograms. Good. I would be tempted here to put, just to save some writing, I know you guys want to save writing anytime possible. I would be tempted to put both sets of opposite angles on the same line and use the opposite angles theorem for just that one line and have two sets there. So I'd probably put angle G congruent to angle HJN. And angle KJM congruent to angle L. All right. Now, do you agree to use the transitive property? We have to have that stringing together part. Like this is congruent to this, and that same thing is congruent to the third. And so the first and third are congruent. Remember that? So we have to have, like right now it's not going to work. G, HJN. I would need an HJN here, correct? And then L to string it together to use the transitive property. So that's why that vertical angles theorem is important in this one. We need to have, say that angle HJN is congruent to angle KJM with the vertical angles theorem. And I guess to be really thorough, You could kind of decide. It doesn't matter whether you substitute in HJN up here for KJM or put a KJM in place of HJN. Whatever you do, you just have to have these match up so you have that transitive property, okay, strung together. That's probably the most thorough way to do it, to use the transitive property. We call it substitution, but you remember substitution was used for equal signs mainly. Similar application. Transitive property we only use for congruence. So we're rewriting line 2, but with a HJN replacing, I'll put in a box the one that's getting replaced with the transitive property. The KJM. Actually going to be 2 transitive properties in a row here. So that was needed to get it lined up properly. And then now that we have it set up, we can say angle G is congruent to angle L also by the transitive property. Does that make sense? Sometimes it feels like we go just long enough without proofs that it's like, to remind myself of certain things, but that one's not too bad. Questions on that? All right, couple things. So you guys had to do 2 through 18 even. Okay, Mrs. Wolf's class did all of the assignment tonight for homework. Okay, we broke it up into 2 nights. So you guys are going to have some problems that have to do with what we just did. And then I'm actually going to have you guys pre-copy a couple properties in the tomorrow's notes, just so we're not rushing through a lesson. All right. So tonight's not a full night of homework. It's only 4 problems, and then copying down a little bit from the 7-3 notes. Someone's phone's gone off again. This isn't? It sounds like a timer. It's the same time. Oh, man. Yeah. All right. So I want to walk you through. All right. So those 4 problems, and then let's go to in the books. Here's what you'll need to do to copy down those things from 7-3. They're going to look very similar to what we did in the last section. All right. Come on. All right. make sure I match them up to what you guys have. Ooh, they're a little out of order. Okay. So you're going to have to match them up based on the picture. So do you see how the first one, number 1, has a pair of tick marks and arrows? So I'm looking for the theorem that has a pair of tick marks and arrows, and there it is. Okay. Now pay attention to what this one actually says. Okay. If one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. What is different? And by the way, that's exactly what you're going to write down. Yes, but listen, let's do another one of them, okay? Number 5 is right here, 7.10. Looks like number 5 on your guided notes. Why are we writing this again if we just did this in the last section? Or are they different? Let's read it. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. There you go. Do you agree in the lesson we just did yesterday? We were told it was a parallelogram. Therefore, opposite sides are congruent. Opposite angles are congruent, right? Do you see how here we just look at this picture and all we can tell is it's a quadrilateral. It has 4 sides. Does it have to be a parallelogram if it has 4 sides? No. But if you see a 4-sided polygon and the diagonals cut each other in half, then it must have been a parallelogram. Do you see how it's like the converse of what we've been doing? Okay, so that's the difference. So you're going to go through those. I'll tell you what, I'll even leave these 2 up on the board right now so you can get started on them.
No, I don't.
This writing it'll allow us to get through most of the lesson tomorrow and actually talk about why these work out. All right, so that's part of the homework. Those 5 conditions, not properties, we're going to call them conditions. And then the 4 homework problems.